In this video we're going to take a look at two of the most popular web fuzzing tools, which are ffuf and wfuzz. So in the last two videos we went through, first of all, brute forcing files and directories, and then brute forcing credentials. So there's a little bit of an overlap. These tools can be used to brute force files and directories and brute force HTTP credentials as well. So they've been covered a little bit in the previous videos, and there's already some really good guides out doing deep dives into these tools. So bearing that in mind, I'm going to try and keep this a little bit shorter on time and just keep some practical examples covering the basics. And we're using the same setup here. We've got Metasploitable 3 running, so there is a vulnerable Windows system and a vulnerable Ubuntu system. We've got an Nmap scan here with all the services running, although it doesn't really matter as long as you've got a HTTP service to test these tools out against. That's all you really need. I also want to apologize in advance. What's probably going to be the worst audio quality of any video yet, considering most of the time I say ffuf, it creates quite a pop with the microphone, so saying fuzz and ffuf throughout this video is not going to be easy. But anyway, as in the previous video, if you don't have any word lists, grab the sec list. It's got a lot of different things for fuzzing. It's got password lists and things like that. You can install it with sudo apt-get if you're in Kali, otherwise you can just download this git repo. Just in case you didn't see the previous videos, I've covered that there. There's also some good cheat sheets out here which I'll link in the description. This isn't really a cheat sheet, it's more of a bible on how to use ffuf, and goes into great detail on all the options. Highly recommend you check it out, and the video as well. I've got a bit of a shorter cheat sheet here which is kind of just covering the help menu and some of the examples, and the same for wfuzz, and then just the documentation for wfuzz here. So I'll throw all that in the description, but I mean typically whenever I'm running these things it's normally just as easy to open up the man page or just to bring up the help menu so you can get an idea with some examples of whatever you're trying to run, and get just kind of a little shorthand reference as to what the options are. So while we've got the help menu up, let's go through some of the key features. This is for ffuf, but essentially both tools are very similar. wfuzz is an older fuzzer written in Python, and this is a newer one written in Go. And most of my experience previously was with wfuzz, so I'm making the switch now to ffuf and just kind of checking them both out. It seems like most of the options are essentially the same, and even the syntax is very similar, so we'll have a look at the speed and performance differences, which are going to be the main takeaway from this. So just before we go through some of these help options, let's have a look at an example command. So if we run ffuf-w wordlist against this URL, this is essentially going to try each word in this word list. It's going to replace the fuzz keyword each time, and then we have -mc all here, so this is going to match the code in this case. So you might want to say that, let's think of an example here. If you are trying to brute force some login credentials, maybe every time you put in an incorrect credentials you get a 401. So you might want to say that we want to match error code or status code 200, and then you won't be printing out every response. You'll only print out responses that come back with a 200 OK. The filter is basically the opposite of that, so you just reverse in that. If you want to say you want to filter by 200, it means you don't want to see any 200. If you say you want to match by 200, it means that's all you want to see. So we have some other options here. Let's talk through some of those. So in a case where let's say a web server gives you a 200 status code whether your login is successful or not, then what you're going to need to do is look at the size of the response, so either the number of lines, the size, or the words. These are basically just different values representing the same sort of thing. And if for example the response is the exact same size regardless of whether the login is successful or not, so you get the same status code and you get the same size of response, then you might want to match it by regex and say, okay, well we want to see, does it have a message saying login successful, or does it say login failed? So that's essentially how the matcher and a filter option works. We then have fs here, so they're filtering by the response size as well, and -c, so it's in a colored output, and then -v, I guess, for verbose mode. So that's just an example of how to fuzz the directories on a website. We have another example here which is using a host header, so you can see here it's -h if you want to use a header, so you could specify host, but you could also specify other things in here, cookies and user agents and different parameters. We'll have a look at that shortly, and then they're matching the code 200. And then in this example, we're sending post data. So they've actually used the -x post here, but if you're providing the -d to provide the actual post data, then it will detect that it's a post response already. You don't actually need to provide that. And in that case, they're using regex to filter by the error. So, one final example, filtering by multiple locations. So if you have multiple word lists, for example, let's say you are brute forcing a username and a password, you might want to provide a username list and then a password list, and then this is how you'll be able to specify them for fuzzing as well. So we'll go through some examples anyway, but just to show that to begin with. While we've got this help menu up, let's just see what other options we have as well. So we saw that we can set our header values, we can set the HTTP method, we can also set our cookie data, so similarly using the key and value pairs but separated by an equals instead of a colon. So this is basically just how cookies are specified anyway, so you can just copy those straight from your dev tools or from Burp. Post data, we saw that as well. Follow redirect, so this is false by default, you might want to set that to true. You can scan recursively, so if we're scanning files and directories, what depth do you want? If you find a folder, do you want to keep scanning for files and folders in that directory, and do you want to keep doing that for files and folders in that directory, etc. We have a replay proxy, we have our timeout proxy URL, so we might want to send our requests through Burp Suite, for example, on the local host 8080, and then we can modify requests as they go, or look at the responses in Burp Suite. We can set the threads with the -t flag. We can set the mode, so for example, if we're brute forcing usernames and passwords, if you have a list of usernames and passwords, do you want to try every password on every username, or do you want to try them as username password pairs? So you try the first username with the first password, you try the second username with the second password, etc. Or do you want to try the first username with every password and then the second username with every password until you get through it? You can write your outputs as well. So yeah, this is some of the general options. Let's go and try out some of the commands. So before we go any further, let's just get the comparison of the two tools out of the way. So we know they're both fairly similar in terms of their functionality. If we have a look at the wfuzz help menu, it's very similar. We can show and hide responses based on all the same criteria, the regex, the status codes, the size. We can specify cookie, post data, header data with all the same syntax, and our method, our word list, URL is pretty much all the same. We can specify our recursion depth, or whether we want to follow redirections, the number of threads, our proxy, etc. So really what we need to compare them on is the speed and the performance in terms of the system performance and how much it uses our CPU and our memory. So whenever I was looking into this, I didn't really know too much about the differences between the tools. My experience has been with wfuzz mostly whenever I was doing my OSCP. I've been stuck kind of with academic work for a little while. And I found that somebody had recently published a thesis comparing the two tools, and I was quite interested to see that myself, because I just basically assumed that, based on what everybody was saying, that ffuf was a new, improved, faster wfuzz. And in this case, they've obviously spent a decent amount of time setting up an experiment and, well, writing the thesis, but there seems to be some flaws with the experiment. They did find that, or they concluded that wfuzz was actually a lot faster as well as more user-friendly than ffuf, and ffuf only defeated it in terms of the memory footprint, which was significantly different. They did admit that. However, they only ran this locally against DVWA. I didn't test it against any remote sites, and as far as I can see, they only ran the test once. I'm not really too sure what their setup was that led to the results, but I posted this on Twitter to see if anybody disagreed with the conclusion of this thesis, and quickly people did disagree and demonstrated that ffuf is in fact quite a bit faster than wfuzz. I tested this out myself, and even running, whether it's local or remote, it seems to be a lot faster and definitely a lot better performance in terms of the CPU and memory. So let's try a couple of tests and see how it goes. We can time a Let's time a command here, so we'll do wfuzz, we'll pass in a word list of seclist, discovery, web content, common.txt, set it to 10 threads, which I think is the default for wfuzz anyway, but for ffuf it's 40 I believe, and we can hide the 404 codes, and I'm just setting this to fuzz the ffuf site, and we'll run basically the same command with ffuf as well and see what we get. So let's run time ffuf-w. I'll wait until that completes anyway. Web content, common, and we want to set the threads to 10 again. We want to filter the 404s and then just provide the URL. I was a little concerned just because this was HTTPS, and I noticed whenever running wfuzz that it gives some error about the PySSL library. I wasn't too sure if that, but I tested it against HTTP and HTTPS and locally and remotely, and it was basically the same kind of results. So we can see here wfuzz, it ran, we have a real time of nearly 28 seconds, but you can see how high the user and the system time is there as well. Let's try and run this now, the exact same fuzz with ffuf, and see what we get. So that took a relatively similar amount of time to complete, 25 seconds instead of 28 roughly, but look at the difference in the user and assist time. So combined around 3 seconds, combined here we have close to the full time, so well actually basically nearly 30 seconds. So that's nearly 10 times the user and sys. So I don't know too much about the time and performance here. Let's go and have a look. Time, real versus user sys, and get a better explanation than I'll be able to give off the top of my head. So our real time is a wall clock time from start to finish. This is the elapsed time, so the time that we started the process and the time that it ends. But the important bit here is the user and assist time, which is the amount of CPU time spent in user mode and then the amount of CPU time spent in the kernel within the process. So you can see as an example here, user plus sys will tell you how much actual CPU time your process has used. And if we go back to our example, our user and our sys time here is nearly 30 seconds, and here is about 3 seconds. So that's testing it against a remote site. I tested this a couple of times on a couple of sites and got very similar results. Let's try it against a local site anyway, just to see. So I'm going to test it against the 10.10.10.5, which we can go and take a look at here. Is just a HTTP service which is running on Metasploitable. So this is a local service. Let's try and run it. Let's actually increase the number of threads as well. I'll set this to, I think the default here is 40, but I'll set it to 40. This is for ffuf. Let's go and prepare this one as well. So I'm going to set this to 40 threads and the same IP. So that came back 1 second with user and assist time, which is coming up to around 2 seconds there. Let's try and run it with wfuzz. And came back quite quickly, but still you're looking at like 5 times the amount of real time there, and still significantly more user and sys time as well. So yeah, sorry to hate on this thesis, but it looks like ffuf is definitely a lot faster and better performing than wfuzz, and I'll certainly be making the switch over to ffuf as my main fuzzing tool from now on. So let's go and try out some different commands anyway. I will test them with both tools just in case you're interested, but generally the syntax is pretty much the same anyway. So in that last example we were fuzzing files on the local server. Let's change this to the same word list that we used in the directory and file fuzzing video. So user share word lists, dirbuster, directory list, common, no, medium, no, lowercase, 2.3, medium. I'm going to set that to, I'll just leave it on the default number of threads, And so this would just be fuzz in the directories in this case. You can see here that we have the hash as an example. So if we actually go to the site, let's go to 10.10.10.5. If we try to access a file or a directory like hello, we get not the directory you're looking for. If we try and put a hash in here, it's going to actually show us the correct page because it isn't going to be submitted as part of the URL. So go back there, that's completed. What if we want to fuzz the file extensions as well though? So this is quite easy to do with ffuf. We can just use the -e command here, and we can say that we want to look for PHP files, text files, HTML files, and it'll try and find each directory in the list, and then it'll also append each one of those extensions to the directory to test that. In terms of doing this with wfuzz, it doesn't seem to be quite as easy. So the only way that I could determine to do this would be to create an actual word list. So if we say here extensions.txt and then put in here PHP, TXT, HTML, and then basically specify them as two separate word lists. So let's go, I'll change the word list here as well. User share word list, dirbuster, directory list, medium, no, lowercase, medium. Okay, set that on the default threads, which will be 10 in this case, I believe. And what we need to do here, then, that's our first word list, but for our second word list then we want to specify our extensions.txt, and then we can just go and put fuzz, and we need to put a 2 in there just to show that it's the second parameter that's being fuzzed. Let's go back here. So it tried to fuzz those files and directories. Let's try here with wfuzz as well. So maybe there is another way to do extensions here, but that's the only way that I could determine to do that. Obviously we could just do the extensions one at a time as well, so we could just cancel that, and instead of providing two word lists, we could just say we want to fuzz PHP files. We'll fuzz all the PHP files, and then once we've identified any, we'll go back and do the same with TXT files and HTML files. You could do a similar thing with ffuf as well if you preferred to use that syntax, or if you weren't just checking for extensions. So rather than passing in -e there, we could say fuzz dot, in fact let me say file.ext, and then whenever we specify the word list we can say at this one we'll put :file, and then we'll specify another word list, extensions, and we'll put :ext, and that's basically just another way of providing multiple word lists. So we didn't need to do that because we can test by extensions, but in the case where we can't do that, that's another option for us. If we wanted to try and fuzz some kind of headers as well, we could do that here. So let's just say that let's say we're dealing with a website that restricts access based on the user agent, and we might want to fuzz the user agents instead. So we could set our word list here. Let me set this to seclists, fuzzing, user agents, and just go for user agents.fuzz.txt. And normally we'd be providing fuzz in our URL, but in this case we want to say that our header is going to be user agent and then fuzz. So that's what we're actually going to be looping through, and we might be trying to test for the code. In this case we're hiding anything that's 404, but we might also want to set this to filter by the size or regex or something like that. In this case we're not actually looking for, it's not going to be any different regardless of what our user agent is going to be, so I'm not going to set that, but we could set that to run. In fact, what we could also do, let me open up, let me cancel that. I'm going to open up Wireshark, So you could open up Wireshark, or you could, even better, you could send this through Burp Suite if you wanted to have a look at the requests. I'm just going to capture some of the traffic there, and if we start that running, you can actually see it going through our network traffic here. So we can have a look at the HTTP, and if we start to scroll through some of these, we'll see that we have our user agent changing. It'd look a little bit better in Burp Suite really. Let me stop that. But we can see that our user agent is being updated. So that basically applies. I'm not going to go through all the examples because this basically applies to any of the different parameters we can provide. If we're providing, post data, I think is, let me just wfuzz-h. Post data in this case is -d, so we could specify, instead of fuzzing through the user agent, we might be fuzzing through post data, which could be username equals fuzz and password equals, I don't know, super secure. We could fuzz that as well. We could just as easily be sending that as a cookie as well, which is the exact same syntax as well. So sometimes the credentials are in cookies. If you go through some of the Burp Suite, Portswigger's Web Security Academy, some of the challenges on there, I remember going through one which required fuzzing the cookie. In fact, we can go through an example from the Web Security Academy. So let's just open up the Web Security Academy here. This has some amazing challenges on it. If you go to where is it? Academy, and you have labs on here. You have a lot of learning materials, and then you have vulnerability labs as well. So you can go through based on different categories: SQL injection, cross-site scripting, etc. And some of these are great for testing out tools, whether it's obviously Burp Suite, since that's by portswigger, so it's the main tool used in these labs. But you can also test out things like ffuf and wfuzz as well. One of the examples I remember doing with this was fuzzing a two-factor authentication code, and I do remember at the time that one of the issues was that and I may be wrong with this, maybe somebody can correct me, but in wfuzz you can specify a range, so you can say -z range and then say 000 to 999, and then we could specify our cookie and say that at the time it was like MFA token equals, and that was what we wanted to fuzz. It could be any one of those PIN numbers essentially. So you try the password and then you need to get the correct PIN number as the two-factor authentication. So with wfuzz you can just provide it as this syntax, but there doesn't seem to be a way to do that with ffuf. So the only way to do it would be to first basically do a for I in and loop through all of them. You can just print those to a file and then read those in as a file. Maybe somebody can correct me if I'm wrong, but I couldn't find that option in ffuf. So let's go and test a basic example here anyway. We'll just do a little brute force in lab. I think it's down here at the access control, or let me just search for brutes. So we'll just do a username enumeration via different responses. So there's a few different authentication labs here which you'll be able to test out the fuzzing tools on. Let's go on to the most basic one here, where essentially we're given a list of usernames and a list of passwords, and we need to try and brute force them. So I'm going to take a list of the usernames. We'll just test this out with ffuf rather than wfuzz. I'm going to make the permanent switch myself now for my future hacking efforts, so we'll just continue with that for the rest of the video. Let's grab the passwords as well. So these labs would have been probably better examples for testing out some of these pen testing videos I've been doing than the Metasploitable 3 setup, but as long as we're able to see the tools and the different options, then that's the main thing. So we save our two word lists here. Let's go and open up the actual lab so we can access the lab. We need to brute force the user's password in this case to access their account page. So Can take a little while for the lab to boot up. Let's go and get this started anyway. So we're going to want to do, ffuf. We can use -c for the colored output. We can do -fc if we wanted to filter by code. Let's just leave it for now. Let's see what we get. We can set our word list first of all for users.txt, and then we have obviously another word list which is our pass.txt. And we could, if we wanted to, specify these. Let me actually do that. I'll say user and pass, and then we're going to want to specify, we're going to need to provide a cookie here because you have to log in to use this portswigger's Web Security Academy. So let's go, here's the lab right here, so we'll go to my account. Here's our login form. I'm going to open up the dev tools, so you need to either get Burp Suite up and running here to have a look at the proxy, or just open up your developer tools. We can have a look at our network tab. I'm going to send a login request, so let's just do admin, password, login, and we'll get our network request here. So we can see that it's sending off this post request. We can have a look at our request headers, our response headers, our cookies which are sent across, and any post data, form data. So we need to provide all these things, right? So some of these things might be required in terms of the headers. Just looking at them at the moment, I don't think they are. I think the only thing we're going to need is the cookie, and we could provide the cookie as header. So I've already got -h in here, so we could say cookie is and then session equals, or we could have provided it with a -b flag, so -b session equals, and that's the same, both the same thing, slightly different syntax. So we've got our cookie there. We also know that we have form data to provide, and this is the data we're interested in. So if you hit raw here, you'll be able to grab a copy of that, and then we can just go ahead and send that in as post data -d. And these are the two parameters we want to fuzz. So what are our fuzzing keywords? We have user, and then we have pass. And then finally we need to provide our URL. So what's the URL that we're actually trying to log in at? And if we go back here, we can see that this was where the post request went to. So I'm going to take a copy of that. Let's minimize that so you can see it a little better. And let's try and run that, see what we get. See, we're getting all these status codes 200 coming back. So essentially everything's coming back with the same thing. So eventually we're going to get something which is either a different status code or a different size or has some different text in it. It's not quite very easy to see that at the moment. So what I'm going to do is I'm going to go back and say we want to filter codes 200. So quite often, if you get a 200 error code or status code whenever you're trying to log in, then quite often whenever you get a successful code, it'll redirect to your account page. So you'll get a 301 redirect taking you to the new location. And you can see that as this is running as well, we have some information about the scan that we've set up. So we can see that we've set our header as cookie, our session ID, and we have our data, which we're fuzzing, the username and the password. Our threads is set to 40, so that was the default. And then you can see that we're matching everything, but we're filtering out the 200 responses that we don't want to see. We're not following redirects, so we could have enabled that as well. But let's leave this running and see how long it takes. Okay, so you can see there that we've got our user, and pass Jordan, so we can go and take these now to the Security Academy, user and Jordan, log in, and you'll see there we've successfully logged in, so we solved the lab. So that's probably going to close the lab down now, so I'm expecting this to start throwing some errors. Let's just exit that. Another easier way that we could have done that would have been to grab the request from DevTools or from Burp. So if you just go and take an actual copy of this request and then save it to a file, let me see if that even copied. Save that to a file, and then whatever we wanted to fuzz here, so well, that wasn't the right request for me to grab. It should have been the request to with the username and the password here. But whatever we want to fuzz, we could have, so if it was user equals, we would just set this to fuzz, and then pass equals, for example, fuzz2 fuzz, and then we could just say that we want to run this again, but we'll just do ffuf-request, and then pass in the, well, we need to pass in the word list, so we would pass in our request first of all, new.request, and then pass in our word list of user and our word list of pass as well. Obviously in this case, I believe that site's probably it's probably removed this lab site. Let me have a look. It actually didn't. Okay, but so yeah, that's another way to do it. If you have a request with a lot of different headers and things like that, and you're not sure which ones are important and which ones aren't, or you're just short for time and you just want to grab the request quickly from Burp Suite or from the dev tools, that's another option. It's something I quite often do with SQL map as well. Anyway, I think that'll wrap it up for this video. So if you want to know more about ffuf and how to use it, definitely check out Codingo and Insider PhD's videos and this documentation, because there's a lot more than I could have possibly covered. It goes into great detail. I was just trying to give a bit of an overview of the two most popular tools and a bit of a comparison, because I was looking to make the switch myself and wasn't exactly sure what the benefits were. So yeah, I hope you've enjoyed this video. Next week I'm going to put out another video in this series on using Metasploit to pwn one of the services, because we haven't actually exploited anything yet. But after that I'm going to resume some CTF and reverse engineering and pwn videos, and just periodically add to this pen testing series whenever there's a new tool that I'm checking out or something interesting to look at. Anyway, yeah, any questions, comments, leave them down below. Thanks.